All right, so hopefully some of the rest of these folks will join us here, but there's a little bit more in section 1.8 that we didn't talk about last time. We translated, but we didn't talk about one other thing. And then we've got section 1.9 yet to talk about in chapter 1. So what we're going to discuss first is evaluating an expression given a number for the given variable in the problem. So the first thing we're going to do is we're going to write down the expression, and then we're going to take the variable out of the expression and replace it with a set of parentheses to hold the spot. So sort of like the football game last night when Mahomes hurt his ankle again, people were wondering if they were going to have to put a substitute in or not. So you take the variable out, you replace the variable with a set of parentheses, and then you substitute the number that's given. And for practical purposes, those two steps are done sort of at the same time, but for note-taking purposes, I'll have them separate for today. And then you follow the order of operations until you have just a numerical result. And if your answer is a fraction, you need to simplify your fraction as well. So here's an expression. And the directions are to evaluate, in other words, find the value of that expression, when, or sometimes they say for. And then they give you the name of the variable and they give you a number to substitute in. So the first thing we're going to do is write down the expression exactly like it is. Then we're going to take the variable out, and everywhere we used to see the variable, we'll put a set of parentheses. So the variable, the x, comes out of the expression, and the parentheses are a placeholder for that expression, for that variable where it used to be. And then inside the parentheses, we'll put the number that they gave us. Inside those two parentheses, there's just a number. But we also have an absolute value in this expression. If you have an absolute value in the expression, before you can do the absolute value, you have to have a single number inside the absolute value, which we do. But before you can do any operation outside of the absolute value, you have to do the absolute value. Also, there are two unwritten implicit multiplications that it might help to make explicit. So we take the variable out. We use parentheses as a placeholder. Then we substitute. And then we follow the order of operations. So we need to find the absolute value of 4 first. 4 is 4 units. From 0 on the number line. Exponents are next. Four to the second means 4 times 4. That's 16. Then we multiply from left to right. 3 times 4 is 12. Then the 5 times the 16 is 80. But subtracting positive 80 is the same as adding negative 80. And when we add a positive and a negative, they go to war. Team with the most players wins. So they could ask us the same question, but give us a different number to substitute in. So we're going to start the same way. We're going to copy down the original expression. Then we're going to remove the variable and use parentheses as a placeholder. And then inside those parentheses, we're going to substitute this new number, -6. And make sure your exponent is outside your parentheses. We have to do absolute value before we can do any operation outside it. The absolute value of -6 is 6. Then we do exponents before we multiply or we add or subtract. -6 in parentheses to the second power means -6 times -6. That's +36. Over here, I'm just going to put the +36. I'm gonna do any calculations that I need to off to the side. Then we multiply from left to right. 3 times 6 is 18. Then 5 times 36 is 180. And then subtracting a positive is the same thing as adding a negative. And we're adding a negative to a positive, so they go to war. The negative team wins by 162. Sometimes you're given a fraction to substitute in for the variable. When I'm ready to do that, I'm probably going to use 2 lines on my paper to write the fraction, 2/3. And I can think of the whole number 3 as 3/1 minus 5/1 times parentheses. And the whole parentheses is being raised to the second power. And I'm substituting in my fraction, 2/3. Before I can do either this multiplication or that subtraction, I have to do the absolute value. The absolute value of 2/3 is 2/3. Then exponents before multiplication. 2/3 in parentheses followed by an exponent of 2 means 2/3 times 2/3. So that's 4/9. And then I have to multiply before I add or subtract. Work left to right. 3 times 2/3 is 6/3. Then 5/1 times 4/9 is 20/9. I'm subtracting a positive. That's the same as adding a negative. But in order to add fractions, I need a common denominator. So I have 18/9 plus negative 20/9. And when I add them together, I get negative 2/9. And 2 is not a factor of 9. So that fraction doesn't simplify. Sometimes they ask you to complete a table of values where on the top left of the table is a variable and on the top right of the table is an expression in that variable. You need to do your work in a separate place, and then you're going to just put your results in the table. So what this problem is asking, it's asking 3 separate questions. The first question is, when x is 2, what is the value of this expression? What does this expression simplify to when x is 2? And then the second question, what happens when x is -4? And the third question, what happens when x is 1/6? So when x is 2, here's our original expression, and we're going to do exactly the same work. We're going to take the variable out and replace it with a set of parentheses. And inside the parentheses, we're going to put that number, in this case 2. We do exponents before we multiply or subtract. 2 times 2 is 4. We multiply from left to right. -5 times 2 is -10. 3 times 4 is 12. Subtracting a positive is the same as adding a negative. These are both on the negative team, so this time they join forces. And then they asked us to do the problem again when we substitute in -4 for the variable. Exponent first. -4 inside parentheses with a 2 as an exponent outside the parentheses means -4 times itself, which is +16. Because as soon as you take the x out, you put the parentheses exactly where you used to see the variable. And then you put the number that they gave you inside the parentheses. Yep. And then we're going to do the multiplication on the left first. This time a negative times a negative is a positive. And then 3 times 16 is 48. But to subtract the 48, we'll think of adding negative 48 instead. They go to war. Negative team wins. And they gave us a third number to substitute in. This time it's a fraction, so I'm going to plan ahead and make my parentheses tall enough so that I can use 2 lines on my paper for my fractions. And whenever you have integers and fractions, we're going to think of all the integers as if they were fractions. We have to do the exponent first. The second power of 1/6 means 1/6 times 1/6. That's 1/36. Then the first multiplication, -5 times positive 1/6. Then the second multiplication, subtracting a positive is the same thing as adding a negative. But in order to add fractions, we need a common denominator. So we've got -30/36 plus -3/36. So they're both negative. They're going to join forces. And this time there's a common factor. Three times 11 is 33. So -1 times 3 times 11 is -33. And 36 is 3 times 12. The 3's divide out. And we end up with -11/12. Then we're going to use the table of values just to collect our results. This last time, when X was positive 1/6, we got -11/12 for our final answer. The first time when X was 2, the result was -22. And the second time when X was -4, the result was -28. And I can put these three numbers in the table at the beginning of the problem, but for note-taking purposes, I wanted to leave that blank at the beginning. You might be given an expression that has more than one variable in it. In order to evaluate it, you have to be given a number for each of the variables. So this time, I'm going to take the X out, and I'm also going to take the Y out. Where I see X, I'm going to put 4, and where I used to see Y, I'm going to put -6. It's like what you would do if two people got hurt on the same play. You need a substitute for each of them. Exponent first. A negative times a negative is a positive. Then multiply. Work left to right. And subtracting a positive is adding a negative. So before today, or at least before section 1.8, all of our expressions, none of them had variables in them. It was all just numbers. And we were following order of operations. And these problems are sort of a combination. We're starting with an expression that has some variables in it, but then they give us numbers to substitute for the variables. Now in section 1.9, we're going to be simplifying algebraic expressions. In other words, expressions that have variables in them that stay as variables. And there's 4 big ideas in section 1.9. The first we've talked about before, but we need to be reminded of it. And that is, in order to add, we have to have like terms. Once we know that 5 + 3 is 8, then if we have $5 and we add $3, we know we're going to have $8. Or if we have 5 apples and somebody gives us 3 apples, we get 8 apples. Or when we're adding fractions, we have to have a common denominator, but once we do have a common denominator, then we can add them together. When you have a variable, like terms have to have exactly the same variable part. It has to be the same letters with the same exponents. So we can add 5 X's and 3 X's together. Then we'd have 8 X's. Or we could add 5 Y's and 3 more Y's, then we would have 8 Y's. Or if we had 5x squareds and somebody gave us 3 more x squareds, we would have 8 of them, 8x squareds. But if we have 5x and somebody gives us 3 y's, that's what we have, 5 x's and 3 y's. It's like starting with 5 apples and somebody brings home 3 oranges. Now you've got 5 apples and 3 oranges, but we can't actually add them together. Likewise, if we have an x to the second in one term and just a plain old x or x to the first in the second term, those are not exactly the same. So we can't add them together. Or if we have a variable in one term and just a constant in the other term, those are not like terms. We can't add them together. Sometimes we have lots of things that we are trying to add together, lots of terms. Addition is nice. It's commutative, we can change the order. It's associative, we can change the grouping, but subtraction is not nice. So if there's any subtraction in the problem, we're going to change it to adding the opposite first, just like we did for integers. But once we have only addition, then we can reorder the terms. And we want to put like terms physically next to each other so we can think of them as being grouped together. And there are 3 conventions that are 3 rules or 3 strategies, whatever you want to call them, that we agree on. We're going to put variable terms first and constant terms last. If we have different variables, we're going to put them in alphabetical order. And if we have the same variable but with different exponents, we're going to put the term with the highest exponent first and then work our way down. And then once we've done that, we can add our like terms together. Some instructors, if you end up with a 1 times a variable, some instructors will say you must do that multiplication and rewrite it as just that variable. So 1x is the same thing as x, or 1y is the same thing as y. I don't care whether you do that or not. I'd almost rather you write the 1. Likewise, -1 times a variable is the same as the opposite of that variable. And again, some instructors will require that you do the multiplying and some of them won't. At this level, I won't require it. And when you're all done adding, if you end up with a negative coefficient, some instructors will require that you then change that into subtracting a positive. So if you end up with adding a negative somewhere, some instructors will require that then you write it as subtracting a positive. I'd almost rather you didn't. I want you to always think about addition. So leave it as addition. But the answer in the back of the book might have the subtract. Yeah, just fewer symbols. So here's an expression with lots of addition in it. It's even, right?
Yes.
I don't know why my brain was like doubting myself. There is some multiplication in this expression, but all of the multiplications are a number times a variable. None of them are a number times a number, and none of them are a variable times a variable. They're all a number times a variable. So 3 times x, 9 times x, 4 times x, 6 times x. But other than those multiplications, everything else is addition. And addition is nice. We may reorder and we may regroup. The only variable I see is x. And I see only x to the first power. I don't see x to the second power. I don't see x to the third power. Nothing like that. I don't see any y's, just x. So I'm going to write down all of my terms that have x in them first. Then I'm going to write down my constant terms. And if you keep your addition signs lined up, you should have the same number of terms that you started with. Then for now, we'll just do one addition at a time. We'll work from left to right when we can. So 3x plus 9x, that's 12 x's. And then we're going to copy everything else. Then the 12x plus the 4x would be 16x. Copy everything else straight down. The 16x plus 6 more x, that would be 22x. But now, none of the rest of my terms have x in them. They're just constants. So I'm going to leave my 22x alone, and first I'm going to add my 5 and my 7. And then I can add that 12 and that 8 to get 20. So now I just have two terms, but they're not like terms. The first term has a variable X in it, and the second term has the constant 20 in it. Eventually, we'll cheat a little and we'll maybe do two additions at the same time. But for now, we're going to do just one addition at a time. This next problem is similar. Again, there are some multiplications, but again, they're all of the form number times variable. None of them are number times number, and none of them are variable times variable. But this time, not only do we have addition, we also have some subtraction. In the expression. Subtraction is not commutative and not associative. So first, we need to change every subtraction into adding the opposite. So we copy down the 5, we copy down the plus 3x, but then subtracting positive 9x is the same thing as adding negative 9x. And again, some instructors might require you to put the negative 9x in parentheses. Subtracting positive 7 is the same as adding negative 7. Then we're adding 8. But subtracting negative 4x is the same as adding regular old positive 4x. And lastly, we're adding 6 times x. Now we have only addition. No subtraction anymore. So now we may change the order and change the grouping. I've got 4 different terms with x in them. Some of them have positive coefficients, but one of them has a negative coefficient. So I would probably put my 3x first, then my 4x, then my 6x, and then the negative 9x. So I put my positives first, then my negatives. And likewise for my numbers, I have a 5, an 8, and then a negative 7. And then again, for now, we'll do one addition at a time. 3x and 4x is 7x. Copy everything else down on the paper. Going directly down as best you can. 7x and 6x, that would be 13 of them. Copy everything else. Then 13x plus negative 9x would be 4x. And my last 3 terms are all constants. So I'll add my 5 and my 8 together. And then finally, I'll add that result 13 and the -7 is 6. So the equal sign on the left, working directly down. But if we have subtraction, first we have to change it into adding the opposite before we can rearrange our terms. Here's another similar but different example. One of the things when you're doing your practice homework each night, you should be comparing one problem to the next problem. How are they the same? How are they different? What makes this one easier and that one harder? We do have some multiplication, but again, it's always a number times a variable. We can't actually do that multiplication. We don't have any numbers times numbers, and we don't have any variables times variables. But we do have subtraction. So again, we're going to change every subtraction into adding the opposite. Subtracting positive 9y is the same as adding negative 9y. Subtracting 7 is the same as adding -7. And we're adding 8, so we'll leave that. But subtracting a negative is the same as adding a positive. And then we are adding our 6 times x at the end. Now, there's only addition. So now we can reorder and we can regroup. This time there's 2 different variables. There's some y's and there's some x's. In the alphabet, x comes first. So we'll put our 3x and our 6x first. And then our y's, you might want to put the 4y first, then the -9y. And then the constants, there's a 5, an 8, and a -7. (3x plus 6x is 9 times x. Copy the rest. X and y are different variables. So now I'm going to add my 2 y terms together. They go to war. Negative team wins. Five plus 8 is 13. And lastly, the 13 plus the -7 is a +6. And now these 3 terms are all different kinds of terms. The variables are first, the constant is last. The variables are in alphabetical order. So this process that we've been talking about, we're adding like terms. That's what it's called. There are 3 types of multiplication that we are going to see in section 1.9. The first type is where you have a number being multiplied by a set of parentheses. And inside the parentheses, you have a number times a variable. So like 5 parentheses, 3x, close parentheses. There are 2 implicit multiplications that weren't written on the paper. And when I write them on the paper, I see that I have only multiplication, no addition or subtraction this time. And multiplication is associative. I'm allowed to change the grouping when I multiply. If I'm multiplying 3 things together, and if the second thing is grouped with the third thing, I can change that and I can regroup it with the first thing instead. And the reason I want to do that is because I can actually multiply 5 times 3 is 15. So I have 15 times x, which if I want to, I cannot write the multiplication sign. This type of multiplication we see very, very frequently, where you have a number times a parentheses, and inside the parentheses, you have a number times a variable. We know that multiplication is associative. Multiplication is always associative. We do this so often that usually we just do it in our head. So usually when we see 5 parentheses, 3x, close parentheses, just in one step, we write that's the same as 15x. But you have to think to yourself, 5 times 3 times x. And the 5 times 3 is where the 15 comes from. So if we had 5 times parentheses 3 times x to the second, again, I can use the associative property in my head. 5 times 3 is 15. So I have 15 times x to the second. Or if it was 5 times 3y, that would be 15y. But it has to be multiplication between the number and the parentheses And inside the parentheses, it has to be a multiplication between the number and the variable factors, whatever they are. So this is a multiplication and that's a multiplication. This is a multiplication and that's a multiplication. And then it doesn't matter whether the numbers themselves are positive or negative. As long as you've got multiplication outside and multiplication inside, you just multiply the number parts, the coefficients, and the variable part stays the same, whatever it was. So -5 times -3x is going to be a positive 15x. If you want to, you can write 15 times x. That's fine. When there's just a negative sign in front of a parentheses and there's multiplication inside the parentheses, you can think of that two ways. One way is to say the opposite of 3x is equal to -3x. And the opposite of -3x is positive 3x. Or when you see the opposite of 3x, you can write that as -1 times 3 times x. That would be -3x. Or if you have the opposite of -3x, you can think of that as -1 times -3 times x. So that would be positive 3x. Sometimes you will have both a number factor and a variable factor inside two parentheses that are being multiplied together. Again, there's a bunch of hidden implied multiplications. It's 5 times x in parentheses times parentheses 3 times x, close parentheses. There's only multiplication. There's no addition or subtraction. If we want to multiply 4 things together, we don't need parentheses to tell us which to multiply first, because multiplication is nice. So we don't really need the parentheses at all. And we can reorder our factors so we have the same kind of factors grouped next to each other. 5 times 3, we can do that multiplication. And x times x, we could write with an exponent, x to the second. And we could write the remaining multiplication implicitly. This is another situation that we see frequently. And so we do all of these steps in our head. We think to ourselves, 5 times x times 3 times x. We arrange it in our head, 5 times 3 times x times x. 5 times 3, we can do 15. X times x, we can do x to the second. So usually we do that kind of multiplication in one step, 15 x to the second. If you want to do it in 2 steps, if it helps, you could rewrite it as 5 times 3 times x times x. So for number 2, we can think of it as -5 times +3 times x times x. So that would be -15 x to the second. The third one is the same as -5 times -3 times x times x. So a negative times a negative is a positive, and x times x is x to the second. And you can have the multiplication between the 15 and the x. It can be explicit or it can be implicit. Doesn't matter. For problem 4, we've got 5 times x times 3 times y, which is a different variable than x. We'll put our constant factors first. We'll put our variables in alphabetical order. We can multiply the 5 and the 3 is 15. So we have 15 times x times y, which we can write without the multiplication sign. We can write it with an implied multiplication. And there's a third type of multiplication in this section that involves using the distributive property. The full name of the distributive property is the distributive property of multiplication over addition. And we've used this property before to help us when we wanted to multiply something like 5 times 37. If we know what 5 times 37 is, we can add inside the parentheses, because you're supposed to work inside parentheses first, and then just write the answer, which turns out to be 185. But if we think of the 37 as 30 plus 7, then we can think of 5 groups of 30 plus 5 groups of 7. And that's 150 plus 35. We have to do both multiplications before we can add. And we get 185. So when we have only numbers, and the problem looks like 5 times parentheses 30 plus 7, there's 2 ways to do the problem. We can follow the order of operations, work inside parentheses first, or because we have multiplication on the outside and addition on the inside, we can distribute. There are some problems where distributing is the only option. That happens in an example like this, where we have multiplication on the outside of a parentheses. We have addition inside the parentheses, but we are unable to do the addition inside the parentheses because we do not have like terms. So in this situation, we can't add the 3x and the 7 because they're not like terms. So without the distributive property, we would be stuck. But the distributive property tells us that multiplication and addition have this special relationship precisely because multiplication is a shortcut for repeated addition. And so we can rewrite this expression as 5 times 3x plus 5 times 7. 5 times 3x we were doing earlier. We use the associative property in our head and think 5 times 3 then times x. And 5 times 7 is 35. The 5 times 3x plus 7 is not considered simplified because we are able to do the multiplication. The 15x plus 35 is considered simplified. Because we are unable to do either the multiplication, so neither the multiplication nor the addition. And this second version doesn't have parentheses. Here's the first version, we had to have parentheses. So here's another example. Two times parentheses 4x plus 3 . We have multiplication outside, we have addition inside, but they're not like terms. So we are unable to do that addition, but the distributive property allows us to do the multiplication. We have to multiply the 2 by the 4x and plus we need to multiply the 2 by the 3. So we'll have 8x plus 6. And we can cheat, we can do both of those multiplications at the same time because addition comes later. It's possible that you could have lots of terms inside the parentheses. As long as there is stuff that is being added inside the parentheses and a multiplication outside, you can distribute. Also notice that there are 5 terms inside the parentheses, but none of them are like terms. We have to distribute the multiplier that's outside to every term that's inside. So 2 times 7w plus 2 times 4x plus 2 times 6y plus 2 times negative 9z plus 2 times 3. And each of those multiplications we can do by using the associative property in our head. 2 times 7 times w is 14 times w, and we can just write 14w. Plus 2 times 4x is 8x. plus 2 times 6y is 12y, plus 2 times negative 9z is negative 18z, plus 2 times 3 is 6. So as long as you have addition inside and multiplication outside, you can distribute. Sometimes you have lots of addition, lots of terms inside, and some of them are like terms. You could distribute first, but usually it's best to follow the order of operations when you can. So the order of operations says work inside parentheses first. We have a bunch of addition inside the parentheses, 5 terms being added, but we do have like terms. So I'm going to leave the 2 on the outside for now and the multiplication. And on the inside, I've got some y's, I've got some x's, and I've got some constants. I'm going to put my x terms first because x comes before y in the alphabet. Then I'm going to put my y terms. And lastly, my constant term. That's the end of my parentheses. And now inside my parentheses, I can add my x's together. I can add my y's together, and I still have the plus 3. Now I have addition inside and multiplication outside. And inside, all 3 of those terms are different kinds of things. They are not like terms. So now I can distribute my 2. 2 times negative 5x plus 2 times 13y plus 2 times 3. And each of those multiplications has to be done before we add. So we can cheat and we can do all 3 of the multiplications at once. Negative 10x plus 26y plus 6. And then those 3 terms are not like terms, so we can't add them together and we're done. Well, we also know that subtraction is really addition in disguise. We know that if we have addition inside and multiplication outside, we can distribute 5 times 7x plus 5 times 4. That would be 35x plus 20. But if we have subtraction on the inside, first, we're going to change that into adding the opposite. And again, some instructors will make you put parentheses around the negative 4. But now I have addition inside and multiplication outside. And so now I can distribute my 5. Five times 7x 35x, plus 5 times -4 is -20. And then if you want to, you could take adding a negative and rewrite it as subtracting a positive. Sometimes the number out front is itself negative. In this expression, we've got multiplication outside, but inside we've got subtraction. We want addition inside. So -5 times 7x plus -4. Now that we have addition inside, now we can distribute the -5. So we have a -5 times a positive 7x, that's a negative 35x plus, but we have a -5 times a -4, that's a positive 20. Whenever you have the opposite of something that's in parentheses, that's always the same as -1 times that thing. But inside the parentheses, we have a subtraction. Every subtraction is really a disguised addition. Now we have multiplication on the outside and addition on the inside. So we can distribute the -1. So -1 times positive 7x is -7x plus -1 times -4 is positive 4. We can combine some of these ideas. Here's a rather long expression again. Inside the parentheses, we don't have like terms. We do have addition, but they're not like terms. in front of that parentheses, there's an implied multiplication. And then in front of that, there's more addition. The order of operations says work inside parentheses first. But those are not like terms. So we can't. Then we're supposed to do exponents. We don't have any exponents. But we are supposed to multiply before we add. So before I can think about this addition or that addition, I have to do that multiplication. And I'm multiplying 5 by a set of parentheses, and inside the parentheses, I have addition. So I need to distribute my 5. So 5 times the 7x plus 5 times the 4. I still need to multiply before I add. Now I have 2 multiplications. They're separated by an addition. Addition comes later. So 3x plus 6 plus 35x plus 20. Now I'm all done with my multiplications. But in order to add, I need to have like terms. The good news is I have only addition, no subtraction now. So I can reorder my terms and then think of grouping my like terms together. So I'd have 38 x's and I'd have 26 groups of 1. I still have 1 addition, but 38x and 26 are not like terms. And so I'm done. This expression is similar, but this time there are some subtractions. The order of operations says we're supposed to work inside parentheses first. but 7x and 4 are not like terms, so we can't subtract them. So there isn't anything we can do inside the parentheses. And we don't have any exponents. But we do have addition and subtraction and multiplication. And we're supposed to multiply before we add. And of course, every subtraction is really an addition in disguise. So most people, not only inside the parentheses, will they rewrite subtracting +4 as adding -4? But also, instead of thinking subtract +5 times the parentheses, we're going to think add -5 times the parentheses. And we have to multiply before we add. But this time I'm distributing a -5. -5 times 7x plus -5 times -4. I still have to multiply before I add. Since I have only addition, it's okay to change the order of the 4 terms that I am adding so that I can group my like terms together. And I can add my x's together and I can add my 1's together at the same time. But I can't do that last addition because I don't have like terms. Does anybody have, what homework questions do you have from section 1.7? Anything that you got stuck on or from the worksheet from 1.7? Let's compare problems 9, 10, and 11. Is this an expression, an equation, or an inequality or something else? It's an expression. There's no equal sign. There's no greater than or less than sign. Are there any variables? No, just numbers. That means our final answer will be a number. Order of operations. Work inside parentheses first. Do we have any parentheses in this problem? Yep. How many sets of parentheses? Just one. Are there any operations inside the parentheses? There's one addition inside the parentheses. So I'm going to work inside parentheses first. I'm going to copy everything else down. That's going to let my brain think. And inside the parentheses, 4 plus 2 is 6. What do we have inside the parentheses now? Which is a constant, a number. There's no more operations. Do we have any exponents? Yeah. What number is the exponent that you see? 2. And what is the 2 immediately behind? The parentheses, exactly. And what's inside the parentheses? The 6. So what does the second power of parentheses 6 mean? Right. Which is? Good. So now we have 5/12. And now I either have to write the implied multiplication sign, or I need to put my 36 in parentheses. So now we don't have any more exponents. We do have a multiplication. We're multiplying a fraction times an integer. It's going to help to write that integer as if it was a fraction. The strategy for multiplying fractions is to multiply the numerators and multiply the denominators. If I choose to do the multiplications, I get 180 over 12. And then I have to try to see if there's any common factors. 12 is 2 times 6, 6 is 2 times 3. 180 is 18 times 10. 10 is 2 times, or 18 is 2 times 9. The 9 is 3 times 3. The 10 is 2 times 5. So 180 is 2 2s times 2 3s times a 5. And the denominator is 2 2s times a 3. Anything times 1 is itself. So what I have left is 3 times 5 over 1, which is 15 over 1, which is just 15. Or rather than actually multiplying 5 times 36 and 12 times 1, I could have prime factored 36 as 6 times 6. So that would be 2 times 3 times 2 times 3. And 12 is 2 times 2 times 3 times 1. And that would save me a step. Or I may have realized that 36 is 12 times 3. And my denominator is 12 times 1. So I've got 5 times 3 over 1. But in problem 9, we had to add inside the parentheses first. So 5/12 times 6 in parentheses to the second power. But if we look at problem 10, it's a lot of the same numbers, a lot of the same operations. But this time inside the parentheses, there are 3 operations. There's 2 exponents and an addition. First would be 4 times 4. Then would be 2 times 2. And then we'd add inside the parentheses. If you compare problem 11 to problem 10, this time there aren't any parentheses. But there are 2 exponents still. We'd have to do the exponent on the left first. Then the exponent on the right. But because this time we don't have parentheses, we're going to multiply before we add. Whereas in problem 10, because of the parentheses, we had to add before we multiply because the addition was inside the parentheses. And in problem 9, we had to add before we did the exponent because the addition was inside the parentheses. "36 is 36 over 1, 20 is 20 over 1, 16 is 16 over 1. "36 is 3 times 12. 12 is 12 times 1. So our first answer was 15. When we multiply 5/12 times 20, 12 isn't a common factor anymore, but 4 is. So we end up with 5 times 5 over 3. And for the problem in red, 4 is a common factor again. So we end up with 5 times 4 over 3 plus the 4. So we get 20/3 plus 4. which in order to add, we need like terms. We need a common denominator. Four is the same thing as 12/3. We add these together, we've got 32/3. 3 is prime. 3 is not a factor of 32, and so we're done. So we have to pay attention to the details. Where are the parentheses? Where are the exponents? Where aren't there parentheses? Any others of these problems with the fractions? The very beginning of 34 looks like it says 62 times 1/2, but it's really a mixed numeral, which is why we don't like mixed numerals in algebra, because it's hard to know. Are we supposed to multiply or are we supposed to add them? But there's no multiplication symbol between them. Neither one of them is in parentheses. And so this is really 62.5. We have 3 sets of parentheses now. Inside these round parentheses, there's just a number, 3. Inside the square bracket, there's a bunch of operations. Inside the first parentheses, there's 1 operation. And the 2 parentheses are separate from each other. So we should look at the one on the left first. $62 is the same thing as 62/1. And if I want to add a fraction to that, I need a common denominator.
I'm confused how they read transaction addition.
You are supposed to be confused. This is exactly why we don't like mixed numerals in algebra, because that looks like it should be multiplication, but it's not. Because 62 is a numeral, 1/2 is a numeral. If there is nothing written between a whole number and a fraction, it means it's a mixed numeral, not multiplication.
So we just add them?
Yep. So it would have been easier to understand if it had been typed this way, 62 and a half, like that. Then you're more likely to understand that it's a mixed numeral. But if I were to change it just a little bit, and I were to put a dot there, now it's multiplication. And this is exactly why we don't use mixed numerals in algebra. And if we must, we often write it with the fraction part with a slash instead of a horizontal fraction bar. So 62 is the same thing as 124 halves. So 62 and a half is 125 halves. And since there's nothing in front of that, I don't need that parentheses anymore. So now I'm going to look at the other parentheses, the square bracket. There's a division and addition and a multiplication. We multiply and divide before we add, and we work left to right. But to divide by a fraction, first of all, 40 is 40 over 1. To divide by 2/3, that's the same as multiplying by its reciprocal, 3 halves. So we have 120 over 2. Then we have to multiply before we add. So 1/3 times 3 is 3 over 3. We may or may not want to simplify either of those fractions. If we're trying to add, we need a common denominator. If we don't happen to notice that some of the numbers in this problem are nice, the common denominator would be 6. And if I really wanted to, I could get a common denominator with this fraction too, because I'm gonna be subtracting eventually. So I've got 375 over 6 minus the quantity 360 over 6 plus 6 over 6. But inside the brackets, that's 366 over 6. And now inside the brackets, there's just a number. So I don't need them anymore if I don't want them. If I subtract, I get 9 over 6. And then there's a common factor of 3. But the distinction between that and
So the first one, we start to turn it back to a fraction number, right?
mhm. So the first one is an addition. But this one is a multiplication. But that's why we hate mixed numbers. It's easier to understand that it's a mixed numeral if the fraction part is written that way without any space. This particular problem once we were here, there were a couple of options. Three over 3 is of course just 1. And if I were to do that first, then my common denominator for all three of my fractions. Would just be 2 instead of 6. So I would have had 125 halves minus 122 halves. Would be 3 halves. The final answer is the same, 3 halves. So before, when we got a common denominator of 6, we ended up with 9/6, but then there was a common factor. Or in this particular problem, if we hadn't noticed that we have this mixed number, and if we had left it as a mixed numeral, and said to ourselves, to divide, we need to multiply by the reciprocal. Not only is 3/3 equal to 1, but 120 divided by 2 is 60. So we've got 62.5 minus 61. In other words, we've got 62.5 plus negative 61. In other words, we've got 62 plus 1/2 plus negative 61. So we've got 62 plus negative 61 plus 1/2. So we've got 1 plus 1/2. So we've got 2/2 plus 1/2 is 3/2. But that kind of simplifying where the numbers work out really nice like that, that almost never happens. Or from 1 plus 1/2, we could have written 1.5. Which 3/2 is 1.5. So we could have done that too. Okay, so your goal between now and Wednesday is to finish anything in section 7 and before. Finish up section 8 with the algebraic expressions, the ones where you have to substitute in the number. And then the types of problems we were working on earlier today, adding like terms and using the distributive property. And now you should be able to do all 50 problems from WebAssign assignment 1. So if you get all the way through section 9 and all the way through WebAssign, then you can start working on the chapter review and the chapter test. And we'll have some quizzes coming up. I think next Monday is President's Day. So we don't have school next Monday, unfortunately. So bring lots of questions on Wednesday, and then if you, when you run out of questions, then we'll start chapter 2 for in class. Oh, I changed it to like this Saturday or something. Yeah, I will. Maybe not till Wednesday. That's always the danger. Do I put them all at the beginning and then have to adjust them all?